Hey everyone, thanks for watching Indie Devcast, and as always I want to thank all my new subscribers. At the time I'm recording this video we are 74 people on the YouTube channel, so welcome again. It supports my work and the YouTube channel, and if you didn't subscribe, do it right now, and you can also ring that notification bell so you can get notified when I publish a new video. You also have the website indiedevcast.com if you want to subscribe to the RSS feed or just read the different blog posts I'm publishing. On this YouTube channel we talk about game development, mostly with the Rust programming language, but I also have different topics like vertical farming, which will involve some embedded development with the Rust language, and I also have test engineering topics because it's my day job. That's what I'm doing for a living. I create testing tools, frameworks, and test infrastructures. I do that in different languages like TypeScript, Rust of course. And in today's video we talk about one library, Grillon, that I developed for testing HTTP endpoints at the beginning, but maybe I will expand the library for gRPC or other protocols like TCP, UDP, stuff like that. Originally, I created that library to create a service on top of it and let that library open source. But for the moment, I'm only focusing on the library, and today we'll talk about it. So, the redfish/Grillon, that's where you can find the library. And we have a quick README with a very short getting started example. At the time I'm recording the video, we have the 0.50 alpha 1 version that is published. You have a pre-version of what I will show you today. But if you really want the latest version, you can wait for the final 0.50 version, or you can just add this Git repository to your dependencies. You have a small documentation, a small book where you can find different informations, like, oh, you can create a specific client. Let's say, for example, you use a request. By default, we provide an hyper implementation, but you can implement a specific trait for request or for, let's say, for example, surf, Isaac, anything that you are using as a client for HTTP request. You have some information on how to configure requests, and I think the most important part, what are the different predicates and different assertions that you can run against a specific part for your HTTP API. Okay, let's get started. So the first step is to use JSON placeholder. That is like a stubbing service for JSON. So we will use the albums endpoint. That's where we'll get our information, and we will create a new resource. It will just return a fake resource to us, and we'll test that part. So we have two steps to just give you an overview of the library. We'll arrange and act. Arranging is like you create all the different information you need, like how you configure the endpoint, what is the domain you will use to run the HTTP request, maybe you want to configure some specific headers, and then you will act, meaning you will send the HTTP request, and the last step is to assert on it. Because we want to reflect any changes and get a direct feedback of the endpoints under test, we will just use the TDD methodology with the next tests. Next test is recommended to run your test because it's a bit more faster than the regular test runner provided by Rust. And also I'm using the Tokyo runtime for the tests because we have some asynchronous functions with Grillon, and I have this shortened result type that is returned. And because Grillon is a testing library, it will run expectations, and if one of them fail, you will just get it, halting your test and just returning a failure. So we don't really need to undo the errors. Except just for the instance of Grillon, you will see why. And by default, I just return an empty result, which is a okay result. So we'll use that domain. So the first step is to create an instance of Grillon. You see, it's fairly easy. You just have to create a new instance, pass the domain that can be reused when you will create your different assertions. So let's say you have one API and you have multiple endpoints to test. You can configure Grillon to be on that domain. But let's say you want to test, I don't know, a specific path. You can use, you can also put this path to the new instance, and it would be the base URL that you would use. But in our case, we just use the domain. So that's arranging Grillon. And also because, as you can see, we get a result, we can just propagate the error to the test. And if we have any kind of error, it will just fade the test. That's very handy. And then we create the assert structure that is coming from Grillon, where we will we just post a specific payload, and this payload will be sent to the albums. And you have a payload function where you can provide the JSON macro, for example. Let's say we have a payload there with a JSON macro, and let's check, we want something like that. Okay, the ID is something that is dynamically created, so we don't need it. But let's say we create an album for the user ID 1, and because it's about photos, we add this family album. So we provide the album, and then we want to assert these specific requests, and that's when we'll start to assert the different information, and we'll pass to that section. So as you can see, it's quite easy to configure, and Grillon is designed to provide you the good path to configure your tests. So once you assert for an HTTP request, you can't change the HTTP request. So you can't make any mistake in a way, and you will be forced to assert because you consume the HTTP request, and the assert object with just all the different information like the HTTP response headers, the JSON body, the response time, so all the different parts that will be under test. So let's start with the very simple example. So we'll chain all our different expectations. So you would see that you have different parts under test and different predicates. So Grillon is using the functional programming paradigm. So you have high order functions like status, response time, JSON body that will take a specific predicate that is also a function. So very straightforward. You want the status to be a specific status code. Because we are creating a new resource, it should be created, in our case, a created status code 201. And this first expectation will be run, and if we have any failure, we will get it directly on the standard output. But let's say instead of the created enumeration variant, we want to provide directly a number, which is 301. And in that case, you can see we have a Fluent API where we can have different type that can be passed to the different functions. That is very easy to use. So now the status can be between 200 and 299, which is equivalent to a status that is in success. And you have different variants for this function. You could have either client error or either server error, and you can test the different ranges. But in our case, we just want to check that it's a success. So as you can see, we have some helpers that are part of the DSL. And by the way, I'm not providing, let's see. Yeah, for some reason that's not perfect, but I'm not providing, how do you call that? A prelude, but I'm providing a DSL, which is quite the same, but I will certainly rename that to prelude because that's quite standard in the Rust community, in the Rust ecosystem. So I will use a prelude. Okay, the status code is a great way to quickly test your response, but you also want to check the response time. Let's use a very small number. It's in milliseconds, so 100 milliseconds. It's almost impossible to get 100 milliseconds. By the way, you have is let than, that is the specific predicate that you need to use. And it doesn't make sense to really check for a specific response time. We prefer to have like the highest range and check that we are under that threshold. So 100 is very, very low. And as you can see, we have our first failure. So when you have something that is failing, we'll get an output. This output would be made of a result, so it's a failure there. You will get the parts under test, the expected value, and what you received. And as we can see, we have something that is higher than 400 milliseconds. So maybe we could make it pass like that by using 500. But for the moment, we will just keep the failure because I want to show you something. So when we are arranging Grillon to produce the test, we can provide a specific settings for the logs, and we have JSON output, standard assert, and standard output. Standard assert is the default one. It's when you rely on the test runner and you have expectations. So you will have assertions, assert equal, assert not equal, and you will check each time the result is true or false, and it will just prevent the test to continue. But let's say you just want to get all the different assertions and you want to check. So these tests will not fail even if there is a failure, because when you use the standard output directly, it will just log everything and it will not check the result. So because we are returning OK there, we'll not get any failure. So the test will pass. It's quite handy, I think, if you're not using the library for in the test runner, in the default test runner, and you are using it, for example, as a library to build your own library or your own service, and you want to, I don't know, produce some logs. And it's also easy to just debug what's happening, and you get even the past results. So that's quite interesting, and we still have the same failure, but we see that all the different assertions for the status code are passing. Now, if you want to ingest some information and you are building a service and you have a log infrastructure, then you can use the JSON output, and it will produce exactly the same. So the test will still pass because we don't have any assertions that are running with the test runner. But we have JSON logs that you can ingest into your log infrastructure, and yeah, you can just make metrics about it, create alerts about the test failures. So I try to think Grillon around services. So you have the library part that is very expressive, but at the same time, I wanted it to be easy to integrate with a logging infrastructure. It's just the beginning. We have much more to add to the library, but I think it's a good starting point, and I wanted to have logs from the very beginning with different ways to play with it. But let's keep the default one that is just failing when we have a failure. And because the response time 100 is like almost real time, it doesn't really exist. I think we don't have much APIs able to answer under 100 milliseconds. Maybe Spotify. Spotify is about what was maybe at the very beginning. The story of Spotify is incredible, and the engineering behind Spotify too. But yeah, that's for another story. Maybe at that point, you wonder what is the body we receive, or maybe you want to run your own assertion function. Then you have the possibility to use assertfn, where you will use this this assert object to access the JSON body in a closure. So there we'll say, for example, the JSON body is, and then we want to pretty print and debug at the same time, and we want to get the JSON information from the assert. If you wonder what you can retrieve, all those information are accessible. So the test will pass, and we will have our own assert function. There you could say, for example, that assert false, and then it will just fail. So you can add any kind of check if you want to access the JSON body, for example, and make some changes to the different assertion functions. Something is missing from the library. First, you can open an issue on the repository, but you can also waiting by adding your own assert function. Well, that's all, and as you can see, we have the debug log for the JSON body, which will help us to just assert the JSON body. So you have a function, the JSON body, we want it to be exactly this information. So it might be improved because we don't have a JSON body. At some point, I would like to have some kind of diff between the expected and the actual JSON body. But for the moment, I'm printing all the different information, like the type, even in the assertions. It's not just because I'm using the debug information there. Even in assertions, you will get that kind of type information coming from search JSON. So the JSON body should be something specific. Let's start with something straightforward. We want to use the JSON macro, so we can pass that information about the JSON body. So it should be a number taking a bit of time. So it's passing because that's exactly what we are expecting. Just checking if I check the ID. But there maybe you want to use something else, like you have a raw string and you would like to pass something like that, for example. Or you get a string from somewhere else, so anything that you want to provide. You have different types again, and you can check for the ID like that. So you can have a string type, a literate string, and you can use that to just escape the double cuts. And it's working, also working. And you have this last feature that I want to showcase a bit, the JSON path. So you provide a JSON path. It might be not perfect, but for the moment, that's how it's working. So you provide the JSON path, nothing new. You have an expression for that. And then you still have the same expression coming from Grillon. So it's a function that is taking two arguments that time. So it's taking a path and a specific predicate, and it should be 101, okay? But we will have an issue there because, as you can see, the compiler is complaining because we can't provide a number and we need to provide a string or anything that is implemented for this specific DSL of JSON path. And there, I don't know, because that's how JSON path is working, but let's say, for example, we have a failure, so we get a log. And you will see that we have two arrays, because with JSON path, we don't know exactly what we will receive. It might be one element or multiple elements. So by default, we get an array. It's not so ideal, but that's the best way I have for the moment to compare two results. And that's what the JSON path library is also returning, always an array. So that's how I compare, and if I get two different information, it will just fail. And I could also pass an array there, so we could test on different multiple elements and check if it's corresponding to the expected array of elements. That's, I think, all for the library. I wanted to just give you an overview of what I built during all that time, maybe 3 years in that library, part-time library. And now I'm thinking about maybe like some videos about the development, or maybe some live coding sessions where we dive into the code and we try to figure out a better way to express stuff. I have some room for improvements. For example, I would like to add support for gRPC, TCP, UDP, and maybe test the log output into a real infrastructure, so we can explore the log with a Kibana, Elasticsearch, that kind of stuff. Maybe improve the outputs, improve the functionalities like getting a diff. Well, we will have a lot of features that we can add, and you are welcome to contribute to the library or open an issue if you have any problem. I also want to add some support for different HTTP clients. I recently had a chat with another REST contributor. He made different libraries, Stubber, Acer, HTTP, Wiremark RS. You can check out these different libraries. And we had a chat and we talked about some improvements. On his side is creating an implementation for the different HTTP clients. It's not a path I envisioned for Grillon at the beginning, because, well, I prefer to let people use the trait, and it's the response trait, and you can implement it for your own response. Do I have an example there? And by the way, we also have a JSON schema, maybe not directly, but attached to the JSON body. Sorry, I'm just I'm just thinking about it. Yeah, I can't remember, but we should have a schema predicate, yeah. So you can check a schema coming from a file or coming from a direct input, JSON input, and you can do that for the JSON path too. So that's really handy, I think, to just check a schema for a specific subpath. Anyway, that's all for that part. And yeah, the response trait, let me check, maybe I have it somewhere. Yeah, custom response trait. So I provide an example there for request, where you get a response. So maybe I could, instead of just providing the trait, I will still provide the trait, but I think it could be great to just directly implement the trait for the different clients, and yeah, provide different features, optional features, and you can activate requests, exact serve, any kind of client you are using. And by default, still providing Hyper, or maybe I will change the default implementation. I don't know, because Hyper made some changes to the API, which is also something that I need to update. So I have a lot of work for that library. I'm really excited by this library. So I don't have much opportunities for the moment to get feedback. So if you are interested, maybe just check it out and give me some feedback. There is a specific issue on the repository that you can find where I'm asking for feedback. So you can just come there and provide it, and feel free to just say anything you have in mind. I mean, I will not take any offense. If I can improve the library and if it can be used by someone else, but I will be happy because it helps people. For the moment it helps me, but it could help more people. Anyway, thank you very much for watching. I hope you enjoyed the video, you enjoyed the library, it gave you some ideas for testing. And see you next time for another video. I can't say the topic, I don't know. I will certainly pick something around vertical farming. That's what I have in mind for the moment. Not necessarily about Rust this time, but about the system itself. And certainly some game dev videos. Anyway, take care, see you next time, and happy coding. Bye.